They called it a breakthrough, before it had earned the right to be questioned. I felt it the second I stepped into the seminar room. Not the kind of tension that comes from danger, the kind that comes from certainty. People sat like they were already convinced, like the hard part was finished, like all that remained was the victory lap. The slide deck was clean, the presenter was calm, the graphs were polished enough to feel inevitable. That is the moment you should get suspicious. Most people think brilliance is how impressive a theory sounds, but the truth is brilliance is how well it survives simple checks. I've always been the slower kind of thinker, the kind teachers mistake for confused. Not because I'm lost, but because I refuse to move forward until the floor stops shaking. I want the why, not just the what. If I cannot rebuild an idea from scratch, I do not trust my confidence in it. The presenter began with a promise, a messy phenomenon, made understandable by one elegant mechanism. A single idea, a single lever, a single explanation that would turn chaos into order. In this room, elegance was not just beauty, it was status. Heads nodded in sync, not because everyone had tested the claim, but because everyone recognized the social signal. Supporting a brilliant theory early can feel like buying stock in someone's future. Then came the first curve, smooth, perfect, too perfect. The room reacted the way rooms do when a story is winning. A few people leaned forward, as if curiosity had become physical. Someone smiled at the person next to them, like they were sharing a private joke. We're witnessing something important. I opened my notebook and wrote the claim in plain English, stripped of glow and jargon. If I cannot say what the theory is really claiming, I cannot test it. And if I cannot test it, I am not learning. I am renting. The claim reduced to something like this: measure X, adjust Y and Z, will reveal the hidden structure. I underlined Z twice. Z was doing all the magic. That was the first warning. The second warning was quieter. Nobody was asking the annoying questions. Nobody was asking what had to be true for Z to exist. Nobody was asking what happens at the edges, where theories usually break. Everyone was letting the slides do the thinking. I understood why. Skepticism has a cost. Pay it too often, and the invitations stop coming. I waited until the presenter reached the point where confidence becomes contagious. The moment he spoke about generalizing beyond the data set, like it was a casual detail, like reality had already agreed, I raised my hand. The motion felt louder than it should have. The presenter smiled politely, the kind of smile that says, "We can spare 10 seconds for you." So I asked the one question that slows down a fast room. What assumptions are we using, and what happens in the simplest limiting case? He began answering in elegant fog, familiar words, comforting words, words that sound like truth when you are tired. So I offered something that sounded almost childish. Can we do a paper test? Not a new simulation, not more slides, just a sheet of paper. Write the assumptions, check the units, push the edges. A few people smiled like it was a joke, but the room shifted anyway, because everyone sensed it. If the test is harmless, why does it feel dangerous? The presenter uncapped a marker, and that is when the talk stopped being a presentation and became a wager. The marker touched the paper and the room went strangely quiet, like the air itself was waiting. He wrote the core claim again, simplified, clean enough to fit in a sentence. The room liked that. Simple claims feel powerful. Simple claims feel controllable. Simple claims feel like progress. Most people think the hard part of truth is complicated math, but the truth is the hard part is admitting your foundation is missing. I asked him to write down what must be true for the mechanism to work. He started with safe assumptions, the kind people put in introductions. The system is stable. The noise is random. The measurements are independent. Heads nodded, relieved. Assumptions are soothing when they sound familiar. Then I pointed gently at the empty space below the list. And the ones you didn't say. A few laughs. Not cruel, just nervous. The laugh of people who suddenly remember the room has rules. Then came the second line of the paper test, units. I asked him to write the units for X, Y, and the predicted output. Units are the world's grammar. A theory that ignores them is a story pretending to be physics. He wrote them quickly, still confident. Then he combined them to match the equation from the slide, and the units did not match what the slide claimed. Not in a subtle way, in a blunt, unavoidable way. His equation produced something with the units of per second, like a rate, but the slide was interpreting it like a distance, like a magnitude. It was the difference between how fast and how far, dressed up as the same thing. You can rescale a graph to hide that. You cannot rescale reality. The marker paused mid-air. 10 seconds can feel like a year when your audience is watching your certainty. He tried to rescue it the usual way. We normalize, he said. In implementation, the units cancel out. Normalization is not always wrong, but it is the easiest place to hide a missing step. It is the place where mistakes become invisible and still look impressive. So I moved to the third line, edge cases. What happens when X goes to 0, I asked. If the mechanism is real, the effect should weaken when the cause disappears. The simplest world is not a nuisance. It is a judge. He wrote the limiting case, then stopped again. With X at 0, the theory still predicted a strong effect. Order from nothing. Signal without source. That is not a discovery. That is a model manufacturing meaning. If you've ever felt slow in class because you needed the basics to lock in first, you know this moment. It is not about intelligence. It is about refusing to clap for something you cannot justify. He tapped the earlier graph, like the data could rescue the logic. But data can be hypnotic. A model can hug the past perfectly and still be empty inside. A beautiful curve can be a mask for overfitting, where the model learns the noise and calls it structure. So I asked the final question of the paper test, the question that forces a theory to risk embarrassment. What does this predict that could prove it wrong? The room went silent again, but this silence was different. It wasn't confusion. It was recognition. A theory that cannot fail cannot teach you anything. Someone whispered from the back, barely audible. So it's just fitting. The words landed hard because they were simple. No jargon, no escape routes. The presenter capped the marker a little too firmly. He smiled, but the smile had changed. He was no longer presenting a triumph. He was negotiating damage. And now the room had to choose what it valued more, the story it wanted, or the ink that refused to cooperate. The room didn't collapse into outrage. It cooled slowly, like someone had lowered the temperature without announcing it. For a few moments, nobody wanted to be the first person to admit they had been seduced by the slides. People shifted in their chairs. A laptop fan hummed. Someone almost typed, then stopped, as if even the sound of confidence had become risky. Most people think science fails because someone is not smart enough, but the truth is, science fails when status becomes more valuable than correction. The presenter tried to widen the frame. He spoke about the spirit of the idea. He talked about elegance and future refinements. He treated the unit mismatch like a small inconvenience, the kind you fix later. That is how reputations protect themselves. They turn structural problems into details. A senior figure in the front row leaned back and smiled gently, like a parent managing an awkward moment. Let's not get stuck, he said with the tone that translates to, we will handle this without making anyone uncomfortable. A few people laughed, grateful for permission to laugh. The laugh wasn't humor, it was relief. It was the sound of a room trying to return to comfort. I watched the younger researchers. Some looked grateful that the discomfort was being smoothed away. Others looked frustrated, not because the paper test was rude, but because it had forced the room to face an ugly truth. The applause had arrived before the proof. A postdoc caught my eye and gave a small nod. Not applause. Recognition. The kind that says, you saw it too, but I can't afford to say it out loud, because skepticism has a social cost. The more public your correction, the more it feels like an attack. And in many institutions, truth is welcome only when it arrives quietly. The presenter continued anyway, clicking through more graphs, each one polished, each one confident. It was like watching someone try to restore a spell by repeating it with better timing, and I realized something that bothered me more than the mismatch. This wasn't just a weak theory, it was a theory being defended as a reputation. It was already being traded for invitations, citations, funding. It was becoming a social object before it became a tool. After the talk, people gathered around the presenter in small circles, offering support, smoothing the embarrassment, keeping the social fabric intact. Others avoided him entirely, like doubt could spread by proximity. A senior figure approached me near the door and thanked me for engagement. Then he suggested politely that we take concerns offline in the future. The message was clear. Correction is allowed, as long as it does not interrupt the theater. Walking out, I understood the real danger. The paper test had exposed more than a mistake. It exposed incentives. It exposed how quickly a story can become untouchable, not because it is true, but because too many people need it to be true. And if you want to understand why those perfect graphs felt so convincing, you have to name the enemy correctly. The enemy isn't ignorance. The enemy is noise dressed up like meaning. In the hallway, the light felt too bright, like the world was daring me to stay honest. I kept thinking about those graphs, not because they were wrong, but because they were persuasive. The curves were smooth enough to feel like a law of nature. That is the trick. Noise does not always look random. Sometimes it looks like genius. Most people think noise is just messy data, but the truth is, noise becomes dangerous when it forms a story you want to believe. In science, noise is everything you did not intend to measure: instrument drift, bias sampling, hidden correlations, pre-processing choices that quietly steer outcomes. But in human systems, noise also includes pressure: pressure to publish, pressure to impress, pressure to explain something complicated with a simple narrative. When that pressure is strong, randomness starts behaving like it has meaning, because humans are meaning machines. We see faces in clouds. We find patterns in static. We call a coincidence a mechanism and feel proud for noticing it. That is overfitting. Overfitting is when a model learns the past too well and mistakes that memory for understanding. It is a mirror, not a window. You can always make a curve look perfect if you are allowed enough knobs. Choose the dataset. Choose the cleaning method. Choose the smoothing. Choose the model family. Choose the cutoff. Choose the hyperparameters. Each choice is a doorway where confirmation bias can walk in and smile politely. None of this requires bad intent. It only requires hunger. That is why the paper test works. It attacks the hiding places. Units are the first trapdoor. Units force meaning. If the output has the units of per second, but you talk about it like a magnitude, your model is not describing reality. It is describing your expectations. Edge cases are the second trapdoor. If the mechanism is real, it should behave sensibly when you remove the cause or push inputs to extremes. When your model still produces a strong effect at zero input, it is not discovering a law. It is manufacturing a result. Falsifiability is the third trapdoor. A theory should be brave enough to risk being wrong. If it can explain anything after the fact, it predicts nothing before the fact. It is a story with math-shaped decorations. If you've ever felt slow in class, this is why you were right to pause. You weren't slow. You were refusing to borrow certainty without collateral. And here's the part that changes how you see the world. Noise isn't only a data problem. It is a culture problem. When people reward confidence, confidence grows. When people reward elegance, elegance grows. When people reward novelty, novelty grows, even if it is fragile. So the solution cannot be only technical. It must be behavioral. 1 page, 1 pen, 1 minute of boredom. Write assumptions, check units, push edges, demand a prediction that could fail. That is not cynicism. It is respect for reality. And once you learn to hear the difference between signal and story, you start noticing the same pattern everywhere. Which brings us to the real advantage of the answer finder. Back at my desk, the theory was already recovering. Not through correction, through packaging. A colleague sent me the slides with a casual note like, "Still a strong narrative." Another mentioned how well the presenter handled questions, as if composure was evidence. That word again, narrative. Narrative is not the enemy, but narrative without checks is how noise becomes contagious. Most people think speed equals intelligence, but the truth is depth looks slow until it becomes unstoppable. If you've ever felt slow in class, you know this intimately. Some people memorize steps fast. They perform well under familiar conditions. But when the problem changes its costume, the performance collapses. Answer finders build differently. They do not store answers like files. They build a system that can generate answers. They care less about recall and more about reconstruction. They ask why until the structure becomes obvious, not because they enjoy pain, but because they hate fragile knowledge. And here is the uncomfortable truth. Institutions often punish that strength. Schools reward coverage, not comprehension. Labs reward novelty, not durability. Meetings reward confidence, not correctness. In all those places, why sounds like an interruption. That is why people get defensive. A why question forces the room to slow down, and slowing down threatens the social order. So if you want to beat competitors in this niche, do not only tell genius stories. Tell stories that teach viewers how to build minds that cannot be fooled by pretty noise. Here's the toolkit, extracted from the paper test. First, the paper test, as a habit. Before you believe an idea, write 4 lines, assumptions. What must be true for this to work? What am I treating as obvious? Units. What does each symbol mean in the real world? What kind of quantity is this? Edges. What happens at 0? At infinity? In the simplest case where the mechanism should vanish? Failure. What would prove this wrong? If the idea survives those lines, then you earn the right to admire it. Second, explain it simply. Remove the glow words. Remove the jargon. Say it like you're telling a smart friend who hates fluff. If your claim becomes vague when you simplify it, you never had a claim. You had a vibe. Third, toy problems. Shrink the world until you can hold it. Build the smallest version of the problem where the mechanism must still show up. If it disappears in the toy world, it will not magically appear in the real one. Fourth, reconstruction over memorization. Memorization is fast and fragile. Understanding is slower and durable. If you can derive the idea from the foundations, you can survive unfamiliar questions. And this isn't only for exams, it's for life. In meetings, the paper test prevents confident nonsense from steering decisions. In studying, it turns cramming into engineering. In creative work, it forces beauty to pay rent. But there's one more step. The paper test is not just a weapon against bad theories. It is protection against the worst kind of noise, the noise inside your own head. A week later, the theory returned in a friendly reform, not a confession, not a correction, a revision. The claims were slightly smaller, the slides were slightly cleaner, the language was slightly softer, like humility could repair a cracked foundation. People smiled again. Comfort returned. Institutions love comfort. I kept the paper in my notebook, folded once, not as a trophy but as a reminder. Truth is often boring on purpose. Most people think learning is collecting answers, but the truth is, learning is building a machine that can produce answers on demand. That is the difference between renting an idea and owning it. When you rent, you can repeat the language. You might even perform the steps. But you cannot rebuild the idea when it breaks. Your confidence is borrowed. The moment the context changes, panic arrives. Owning looks different. Owning means you can rebuild the idea from first principles. You can explain it plainly. You can test it at the edges. You can predict where it fails. And because you can see the failure mode, you are not terrified of being wrong. Wrong becomes feedback, not shame. If you've ever felt slow in class, you might have been closer to ownership than the fast students were. Speed can be talent, but it can also be camouflage. A person can sprint through steps they do not understand and still win the grade, until life asks a new question. The paper test is how you stop building your life on rented certainty. Run the lines, assumptions, units, edges, and failure. Then apply it where it matters. In meetings, do not argue conclusions. Ask for dependencies. Ask what breaks it. In studying, do not worship formulas. Interrogate them until they become tools. In life, write down the quiet assumptions you repeat to yourself and test them before they test you. Because the most expensive mistakes aren't the ones other people sell you. They're the ones you tell yourself with perfect confidence. So here's the rule you can steal. If you can't pass the paper test, you don't own the idea. You're renting it. And rented ideas always get expensive. Now tell me your moment. Where did memorizing fail you, but understanding saved you? When did you stop renting and start owning? Drop it in the comments. And if you want more stories like this, the kind that cut through brilliant noise and leave you with usable truth, subscribe.